Welcome. So in this lesson, we're now going to be talking about using matrices to represent graphs. And this is where we're going to be introduced to adjacency matrix. So a graph can also be represented as an adjacency matrix. This shows which vertices are adjacent to each other and how many links there are. Adjacency matrices are symmetrical square matrices. Columns and rows add to the degree of the particular vertex. If a loop is involved, it will add to one less than the degree. Note, a loop is represented by a 1 in the adjacency matrix. Now, this is where we need to remember what we saw in the previous lesson. So let me come back to 8a's notes. And remember on the first page here, when we were going through our key definitions, when we were talking about loops, we said something very important. And that is, for a loop counts as a degree 2. But here it says, but only counts for 1 in an adjacency matrix. So what does that mean? Well, if we come back here, remember when we were looking at A here, it's got this loop. So we said this is 1 degree, this is another degree. So the loop counts as 2 degrees. And then of course, we've got this other degree coming out here, which isn't relevant to us now. But remember, when we're dealing with counting up the degrees for a loop, we say that there are 2. But now, when we're dealing with an adjacency matrix, we only count it as 1. So this will make a bit more sense when we actually get to that example here, but you need to keep this in your mind here. All right, let's keep on going. So we'll go through this example and it will make sense of what I'm talking about with these loops here. For example, here is a graph. Here is our adjacency matrix. Let's make sense of this adjacency matrix. This adjacency matrix is saying, how many connections are there from A to A? Well, let's go to A. Would you agree? There are no connections from A to A. This is an isolated vertex right here. What about A to B? Well, this is saying there are 0 connections. And again, that's because A is not connected to B. A is not connected to C. A is not connected to D. That's why they're all zeros. A isn't connected to anything. Let's now go to the next one. How many different ways is B connected to A? Well, B isn't connected to A. That's why there's a 0 there. Let's go to the next one. How many different ways is B connected to B? Well, do you see how I've got this loop going on here? I've got this loop going on. So that means B is connected to B through one way. So that's why we'll put a 1 there. Now, this is where this little note comes into play. This is only counted as 1. We don't count this as 2. As in contrast to when we're counting up the amount of degrees for a loop, we would have said, you know, I've got 1 degree here and 1 degree here. When we're counting up adjacency matrix, the link between B and itself, the loop only counts as 1. Hopefully that makes sense. Make sure to reach out to me if you want me to clarify that a bit more. All right, we keep on going. How many different ways is B connected to C? Through 1 way, because it goes through that way. How many ways is B connected to D? Through 0 ways. There is no connection from B to D. Let's go through the next one now. And hopefully you're getting a sense of what's going on. How many ways is C connected to A? C isn't connected to A. How many different ways is C connected to B? How many ways is C connected to B? Through 1 way. C to B is there. How many ways is C connected to D? 0 ways. C doesn't have a loop going on, so it's not connected to itself. How many ways is C connected to D? It's saying 2 ways. And that's why you can go this way or that way. So there are 2 ways C is connected to D. And then we can go for the last one here. How many different ways is D connected to A? It's not. How many ways is D connected to B? There is no connection between D and B, so we put a 0. How many ways is D connected to C? 2 ways. D is connected to C that way. D is connected to C that way. How many ways is D connected to D? 0 ways, because we don't have a loop going on for D. So let's finish off by reading this. This says element 4, 3, so that's row 4, column 3, so this 2 right here, indicates that there are 2 edges connecting the vertices D and C. So row 4, column 3. And as you can see, it's referring to this one and that one. There are the connections, the edges connecting D and C together. So that is a bit of an introduction to what adjacency matrices are. Hopefully it makes sense. And hopefully this little note here about how we should think about loops is also making sense to you. Make sure to reach out if it isn't.